This thing is fast, man. I mean fast. Hey, what's happening, guys? You saw this particular printer last week in my introduction. This is the Elegoo Neptune 4 Pro. This printer is running the Klipper firmware package and is incredibly fast. I regularly print at speeds of 250 millimeters a second on this. It says it's good for up to 300, but I'm holding it at about 250, just because that's a lot of mass for that bed to be shooting back and forth at that speed. It actually gets kind of scary. So right now it's not printing that fast, obviously. It's laying down a baseline for a honeycomb wall panel. But we'll come back to this once it really starts picking up. What I want to talk to you about in this review is how this printer, which looks remarkably similar to any other bed slinger, is in fact quite different on the inside. Now sure, mechanically they're very similar. They all use basically the same Nemo or the 17 stepper motors. They have belt drives. They have external screens for control. And they both have direct drive extruders. Now this printer here you can easily find for under $200. And it is a great printer. I love it. The new Elegoo Neptune 4 Pro is listing for $299 and is a different animal entirely. In fact, I would put this printer more in line with something like this printer, which is a high-speed Core XY machine, before I would put it in line with this. Again, nothing bad I'm saying against the simple bed slingers, but with Klipper, this is a different beast. So to talk about the specs in this machine, I want to start off by saying I was wrong a moment ago. I said it was good for up to 500 or 300 millimeters a second. Elegoo in its spec sheet says it's good for 500 millimeters per second. And the big difference between the 4 Pro and the 4 are the hardened steel rails and roller wheels on both the tool head and down here on the bed. Let's see what else we have. This has built-in pressure advance, of course, because of Klipper. Pressure advance is controlling the flow rate of the filament as it applies and concerns to speed. So it either, I'm no expert in this yet, so it either speeds it up or slows it down as you go faster or slower. Now, it also has input shaping, which allows the printer to compensate for vibrations. And you'll see this thing start shaking when it starts moving, and that's perfectly normal. Another thing that makes this extremely cool is it has a dual zone heated bed. There is a smaller zone in the center and a larger zone around the outside. It's 150 and 100 watts together, so we're looking at 250 watts. Now, the bed leveling on this, and yes, it does have integrated bed leveling with a little probe in there. It does a 121 point mesh, which is just incredible. Takes a while, but it's incredible. Now, if you know anything about Klipper and you've heard of CAMP, which is Klipper Adaptive Meshing and Purging, you can set CAMP up on here and it will simply probe the part of the bed that you're going to be printing on instead of the whole thing, which is another really cool thing. Now, the build volume on this is 225 by 225 by 265 high, which puts it, in the same category as your standard bed slinger. It has an upgraded dual gear direct drive extruder and it weighs 29 grams. It is really nice. I'll give you a view of it. You can see the gear pull in there. And I love direct drive extruders. I am no fan of Bowden tubes. Even reverse Bowden tubes make my skin crawl. I understand they have their necessities, but I don't like them personally. Now this printer has 4015 ball bearing fans here and here. And wait for this, you see this box here on the back? All right, I'm going to spin you around here so you can get a look. That box has 4 more fans. It is auxiliary part cooling for when you're really cranking up the speed. And it's incredible. It makes a huge difference. It also makes a huge amount of noise, but it works. The maximum speed of the fans is 10,000 RPMs per minute. Well, I guess that's kind of what RPM stands for, isn't it? You can tell I used to work at the Department of Redundancy department. Maximum nozzle temperature up to 300 degrees. So ASA, ABS, polycarbonates, nylon. The hot end can handle it. There's no enclosure, so anything that requires a steady temperature, you're going to have to think twice about printing it here. But the hot end can handle it. The firmware is Klipper. File transfer method is either USB or network. There is a RJ45 jack on the side. Now, I do think Elegoo missed the boat in not putting in Wi-Fi. I understand they skipped it for a price point, but yeah, I think they really missed the boat on it. You can get a Wi-Fi dongle adapter that works, but it might take you 3 or 4 tries to find one. If you are a 3D printing fan and you watch out of Philadelphia, he talks about needing to use one that has the Ralink chip in it, or Ralink, R-A-L-I-N-K. So look for that if you're interested in doing that. And they also tell us supported materials include PLA, ABS, TPU, PETG, nylon. I printed some other stuff on it just fine. For instance, here is an ASA print. It is a Batman bust I got off of Printables. And it is absolutely gorgeous. Here is the 15-minute benchy. I think it's actually 18 minutes. And it looks good. Look at that flagpole on the back, looks good. No stringing. No stringing in the wheelhouse. It's hard to see in white, but you can read the text on the back. And you can see the text on the bottom. I might have had my Z a little low. Very nice. Also, here is the Buddha that comes on the card with it, and it printed fantastically. No troubles whatsoever. I did a few calibration cubes. You can see I didn't take the brim off of that one. I have no complaints. Very nice. All right, we're going to come back to this once it completes the first layer. And we'll get an idea for how fast this thing truly is. All right, the auxiliary part cooling fan is just switched on, which you can hear, I'm sure. And the printer is it's moving. If we come over here, we can actually see some of the specs. Right now, it's only down there at what? Where's my finger? There it is. 22 millimeters a second. But it'll pick up. You can see it was just up to 275 there. Now let me shut off the light in this camera so I'm not blinding us, and we'll come right back and talk about this control panel. Alright, so here we are at the control panel. It is a touch panel. It is removable and on an old style coiled telephone cord. That lump you see there is a magnet, and that just clicks right to it. Very nice. Now right here where it says Elegoo, if your slicer will output a thumbnail, it will show up there just like your high dollar printers. You can see the controls we have here. While we are printing, we can control nozzle temperature. You can see here our printing at 220 degrees, our bed, and then our external bed temperature. You see there is our internal and the external temperatures back to the nozzle. We can control speed. Our print speed is at 100%. We can move it up or down. We can also control our flow. We can increase the percentage. And we can also control our fans and turn them up or down. And it has these modes here. There's normal mode. Giving it a couple seconds. Here's sport mode. Those fans are blowing. I'm going to put it back to normal. There we go. Our filament controls, we have adjustment controls, we have live Z offset stepping, live bed temperature, and we can turn off our filament detector while it's printing, which is a really nice feature. You also have your LED controls. There is a light strip on top and a little spotlight type light on the bottom of the tool head here. But you're not going to spend much time at this control panel. It's good for setting things up, especially you know, if you're getting ready to print something, you can come over here, and when it's not printing, you'll have a different menu here. One of the buttons says prepare. You can hit that, and it'll bring both your hot end and your beds up to temperature, which is, you know, really useful when you're getting ready to print something. Have it ready and have to do that. Now, by default, the Neptune 4 Pro does not do an automatic bed mesh before every print, although it's super simple to do with Klipper, which is what this printer runs on. It comes with Klipper installed here. If you haven't seen my introductory video where we put the printer together, you should definitely check it out. I take the bottom cover off and we take a look at the MKS Pi board that's running in here. That's right, it has its own flavor of a Raspberry Pi inside here, so nothing extra is required. Klipper is installed, the fluid interface is installed, Moonraker is installed. So all of your control for this printer can be handled very simply from the computer. Now, I'll link down below, there is another video that I just did last week called What is Klipper, which will give you a better explanation of what's going on. This is not a great print to try and show you the speed from I'm seeing now, but it is doing its best, and it's cranking up there between 90 and 275 millimeters a second. So when this is finished printing, I will come back and we'll print something else much faster. Now, one other area that I don't like and can easily be fixed is on the bed with the magnetic PEI printed sheet, which is fantastic. There's no way to really align it. I just got whacked by the bed. It's quick. Yeah, there's no way to really align it. So you can see I'm kind of off there a little bit. I'm hanging more off the starboard side than I am the port. It's not a big deal because there is a little bit of space in there. You probably got 3/8 of an inch or so, which is much more than some of these other printers, which if you're off by a little bit, it's going to slam into the bed. I had that happen. It makes the scary grindy noises that nobody likes to hear. Up here we have the filament sensor. Basically, it's just a micro switch in there. Or this one could be optical, I'm not sure, one of the two. But it just looks for the filament to be passing that point. It's plugged in electronically, it's on a swivel. It's very nice. Here is your spool holder. I kind of wish they'd done it like this. I prefer them this way, where the spool is parallel with the gantry as opposed to being perpendicular to it, but it works just fine this way. Now, another thing that differs from your cheaper introductory level bed slingers is the dual Z-axis and the synchronicity of the belt. So let's take a look at that next. Okay, so this is the back of one of the cheaper bed slingers. And you look over here, there's our Y-axis, there's our X-axis, and there's our Z-axis. There's just one lead screw, that white thing with the bearing. I made that to keep it steady. But it's not a dual Z-axis, which can, I'm not saying it will, it can lead to your gantry, your X-axis being canted one way or another. And as somebody who plays around with machining, mills, lathes, that's irritating. I have not experienced any problems with it, and you can keep this pretty tight by adjusting these eccentric nuts here, which are, you know, off-center nuts. And by cranking them one way or another, you can tighten these wheels up on here. But a better solution, and I understand why they did this, you know, this is a low-cost machine. A better solution is to add a Z motor on each side of the machine. I love that. Then you put up your bearings and keep them, you know, nice and flat. And then what they've done to even go a step further is they put a belt on it. And what the belt does is it keeps those two Z motors synchronized, which is very nice. It keeps everything as perpendicular as it possibly can be. Doesn't mean it's perfect, and there are ways to adjust it. If you're familiar with the Prusa printers, when they first boot up, they take their the X gantry and they drive it up to the top so that the screws end up bottoming out, and then they pretty much level themselves. That is an interesting way to do things. I see the advantage of it. I see an engineer sitting in a room who, you know, finally, we have to add one more feature to this. We need a self-tramming gantry, and the guy's just like, oh, really? All right, you asked for it, you got it. But, so this has it, and that's very nice. You'll notice that all of the wires are nice and held in, I don't know what they call these, I call them looms, wire looms. And then our umbilical here is very nicely mounted to the back of that Z gantry. We've got heat shrink tubing. All of the connectors are, of course, labeled. This is our X stop, and you can see the little micro switch in there. Now, I'm not exactly sure what steppers are in here, but I don't believe they're used in the TMC 2209s, because if they were, they would not need the steppers. Over here is my another bed slinger. This is the Cobra Neo. You can see it also uses those, but this printer, which is the just a standard Cobra, has no X-axis end stops because it uses the 2209 steppers, which allows it to use sensorless homing. It just simply detects a spike in current and says, "Oh, don't go any further than that." All right, we're getting some good print speed now. We're still nowhere near as fast as it'll go. That is 155 a minute. But, you know, if you're familiar with, you know, say you have an Ender 3 or, you know, Prusa i3 or something along those lines, a longer or an Anycubic, or even the Neptune 3 Pro or the Neptune 2, you ain't boogieing at this speed, baby. Now, if you take a look at the hardened rail up here, you'll see there's some grease on it, which they provided, and you're definitely going to want to make sure you keep that wheel greased. Same goes for the rail down here for the bed. Now look here, springs and wheels. Is this like 2014? Get rid of them. Replace them with either silicone spacers or hard spacers. Even the cheap bed slingers are doing it. If you like the cool kids Elegoo, get rid of those. Nobody likes dumb wheels and springs. Look at that, we're printing up at for a second we were at 300 millimeters a second. Now we're slow. There we go, 300 millimeters a second. 155, 45. 'Tis the nature of 3D printing that speeds go up, speeds go down. It all depends on what the machine is doing. Okay, I've loaded in the rapid benchy test code. It says it should take 15 minutes. It's 3:39. Okay, I have this position here so you can see the print speed on the one side and the printer itself, the benchy being printed over there. It is ridiculous how fast this prints. It's already 8% complete. I'll come back when it is closer to the end. It is now 3:51 p.m. The print is 65% complete with 6 minutes remaining. And it is boogieing now. I think we're on the, yeah, we're doing the wheelhouse. We'll be up to the roof soon. Okay, the time is 3:53 or so. It says there are 3 minutes left. It has been printing for 13 minutes and it is 80% complete. Well, it looks like it's getting ready to start putting the roof on. Yeah, that's what it's doing, drawing the roof on there now at 200 and 500 millimeters per second. It's swapping back and forth there. I'm assuming the 250 millimeters a second is the print speed, the 500 is the travel speed. But man, when I got my first ANET A8, I don't know, 5, 6, 7 years ago, I would have never believed a 3D printer could behave like this. It's incredible. 87%, 2 minutes left. 91%, 1 minute left. It is 3:56 it looks like. Yep, it's starting to draw the smokestack. There it goes. One of the things I'm going to show you here when this is over is just incredible. When I did the introductory video and I took the bottom cover off to show you guys the board, there is a big old honking supercapacitor on there. And it prevents brownouts. It's amazing. It's good thinking, it's great engineering. Look at that thing go. I'm going to pull out here because it is over. And you can see there it took 17 minutes. Well, that says 18. There's the clock. And there's the part. I know white's hard to see details. Yeah, man, it's... Look at that. Is it the best benchy in the world? No, but it's close. It's real close. So watch. Let me zoom out here. Zoom out, there we go. And focus. And I'm going to flick the switch off. And it's still on. And I come back and boom. I mean, it's only good for a second or so. But it stops you from losing your print, which is fantastic. Just another great feature. The Elegoo Neptune 4 Pro. They list for $299. That is a lot of printer for $299. So I'd like to thank Elegoo for sending this out to us free of charge for our consideration. And I'd like to thank you guys for watching the videos. I wouldn't be here without you. Alright guys, that's it. I'm out. Peace.